All right, so we're on our second section of 1A. So unit 1A, we're on 1A.2, which is rates of change. When you hear rates of change, what word should come to your brain? Slope, okay? That's where we start. That is our baseline for rates of change is slope. Got it? So when we talk about slope, though, slope pertains to a linear function, right? A linear model. So are all functions linear, though? No. So therefore, it has another, that's why we use rates of change for when we're talking about all functions. Okay. Slope is specifically for a line. Okay. Rates of change is for everybody. Got it? All right. All right. So in Precalc, we're going to find rate of change at a point. So we're going to look at it at a specific point and see how is it changing? Is it growing? What happened at that specific point? Okay. Later in AP Calculus, you're going to go there. You're going to talk about instantaneous rates of change. Okay. And that is what we call a derivative. You're going to be taking the derivative of a function. That is not our class. That is in AP Calculus. I love taking derivatives. That was like one of my favorite things to do in calculus. Hopefully you will too. So we are unable to find an instantaneous rate of change. So we only find the rate at a given point, and we approximate as best as we can. By approximating, we look at the patterns in the numbers and how they're changing. Does that make sense? Our main goal is we need to be able to say, is it positive, negative, or if it is zero? Okay, that's our main goal for identifying the rates of change, approximating the rates of change. Is it positive, negative, or zero? All right. Key things to remember when you're describing whether something is positive or negative, you are paying attention to what is the line doing. Remember, if I'm a positive line, I am increasing. If I'm a negative line, I am decreasing. If I'm zero, I am, pretend that's straight, a constant. Okay, we will also compare, and when we compare rates, that goes back to our you may see me write ROC, rates of change, and that equals delta Y over delta X. What does delta Y mean I'm doing? I'm finding the change in your Y. So I will be finding my Y2 minus my Y1, the change in my X2 minus my X1. Is that anything different than what we normally would do with slope? No, we just are calling it slope because it's not a line. Does that make sense? Okay, you have the math skills to do it. Don't let the words throw you off. Got it? All right. So when we're considering rates of change for the going into the test, what you're looking at is you're going to have to be like analyzing different functions, different real world scenarios. So like you could be looking at a graph of a roller coaster. What is the roller coaster doing? How is it increasing or decreasing the speed of the roller coaster, right? If you are, people are like, oh, I don't ever do slope. And I told someone literally on Facebook on Monday, I had a student who like tagged me in a post, another day in my life, I've never used Y equals MX plus B. And I was like, ha ha ha. And I was like, have you ever been driving in your car trying to figure out if you can make it on what little gas you have? Yes, then you used approximation with linearization. Didn't even know it. So she's like, you would say that. Yeah, I did. So stop telling me you didn't use math today. So when you're doing all this, we're going to be focusing on what is it doing? Is it going up or are you going down? That's going to be the most basic way to think about rates of change. Okay. Am I going up? Am I going down? Am I staying the same? Okay. That's why I said our main job is to focus on positive, negative, or zero, right? That's how we know if we're going up, going down. And you have to be able to either visualize that or actually draw it out for yourself so you can see what shape, what pattern is taking place. Make sense? Okay, that's going to be the easiest thing as far as if you accept that, then the test will be easy when you are doing rates of change. Okay, so look here at this little roller coaster ride. So if this is a roller coaster, at the instant point when you are at the top of the or at the bottom, you are not moving. Therefore, the rate of change is zero. So at your max and your mins, your rate of change is zero. The reason why it's zero is because technically I can draw a horizontal line at this point. Does that make sense? If I can draw that horizontal line, therefore, what is the slope of that line? Zero, which is why your rate of change is zero. Does that make sense? Okay. And then from then on, as you're analyzing, you're just saying, what is, if I was to draw a line through that point, what type of line would it be? So at T1 right here, if I drew a line through T1, what type of line is that? Positive. If I'm here at T3 and I draw a line, what type of line is that? Negative. If we can do that, then you can do this. Easy enough? Okay. All right. Fun fact, the fastest roller coaster in the world, if you ever want to go to it, it's in Dubai. It was built in 2010. It goes 149.1 miles per hour. I don't know if you want to go ride that or not, but if you do, if you're a thrill seeker, fun fact, there's this teacher who makes these, and he's now started putting fun facts. So I was like, I guess I'll start sharing the fun facts as well.
Yay.
So here's your fun fact.
Miss Jones, can you take us to Bangladesh?
I'm ignoring you. We're not going to even answer. Okay. So here we go. Example 1. After discussing what I told you, you're going to look at points A, B, and C. Okay. And you're going to identify the rates of change. And what are we just identifying about them?
Rates of change.
Exactly. We're looking to see, is it increasing, decreasing, or constant? Because that tells us whether it's positive or 0. That's all I'm asking. So you're going to identify what is the rate of change, quote unquote, at A, B, and C. And then you're going to tell me in order, list them out, which is from least to greatest. Easy enough? I give you 60 seconds. Go. If y'all haven't caught on, Precalculus is my favorite thing to teach.
Your favorite?
It is. I keep forgetting that on my little presentation thing, it has a built-in timer, and I've been trying to count, and I'm like, why don't you just hit the refresh button on the timer? And I tell myself this all the time, and then I never do it. I'm like, push button. I just did it now. All right. Here we go. So, identifying the slope to the best of what we know so far, right? That's all we're doing. So, we're at point A. At point A, if you drew a line, what type of line did you draw? It is positive. It has a positive rate of change. Agreed? Okay. At point B, if you drew your line, what did it have? It had a negative rate of change. Okay. So, positive. Negative, because we read our graphs from left to right. And then at point C, what do we have? We have a constant. And why is it constant? Because it's not doing anything. It would make a horizontal line, right? So if I was to list what would be my smallest rate of change? B. This is the smallest because it is negative. Does that make sense? This is your smallest rate of change. And then the next one would be C. This is in the middle. And then this is your greatest, your highest. And that's because it is positive. I don't know what that says. I don't. I can't even accept it. Girl, what did you write? Also, I feel like I probably should go to an occupational therapist because I've learned that when I start writing, my hand keeps cramping. I also discovered in Japan that when I try to use chopsticks, my hand also cramps. And so I think something's wrong with my hand.
That reminds me of my trip to Japan.
Why does it matter, like, if it's negative, if it were a greater change, like, you know what I'm saying? Like, on a graph, if there's a bigger change, like a sharper slope.
Because when you're still describing whether something is the order of rates, order is always numerical from least to greatest.
Okay.
And so that's it.
Okay.
It doesn't matter the distance or how long it's on that rate. It's about what is the rate. And so when we put things in numerical order, it's always going to be from least to greatest. And our least is going to always be your negative and work our way into our positives.
Okay, so it could have technically a bigger rate of change.
It could last longer. That rate of change could last. The absolute value, if we were comparing the absolute value of the rate of change, that's different than the actual real life version of it. Okay? Good question. Good question. All right, let's see if we got this again. Here you go. So the next thing I want you to read through is here we have this figure and the graph is G, okay? With 4 labeled points, A, B, C, D. Of the following points, at which is the rate of change the least?
So like the lowest.
Mm-hmm. I want to see how you process this. Oh, let me do my reset of the timer. Got it. 60 seconds gone. What do you think has the least, the smallest rate of change? Your hint for this with our 30 seconds remaining is think of steepness. Think of steepness. Which way though? Which way do you want to be if it's the least? All right, 8 more seconds. 5, 4, 3. Okay, we're off. It's fine. All right, here we go. So, which ones should you automatically eliminate? A and B. Why am I automatically eliminating them? Because they're positive. They have positive ROC. So they couldn't be my smallest, right? Boom, gone. Okay. Next, you're going to look at B and D. They both are negative, but I gave you the hint of the word steepness. Okay. The steeper it is, that means the bigger the rate of change is, but the absolute value is bigger, right? But it's still negative. When we have a negative number, the bigger that number, the absolute value is, that means that it's actually a smaller number, right? It's moving further away from 0. So this one is okay. Oh my gosh, guys, that's a good straight line for me. I need y'all to acknowledge that. And then which is steeper? D. So therefore, that is your smallest, because it would be a larger negative number, quote unquote. Does that make sense?
What?
Because -4 is smaller than -3, correct?
Okay.
Yes?
Yeah.
All right. Okay. Do you feel good about rate of change?
Yes.
Okay, now we're going to move into its cousin, average rate of change. Basically, no, it's not. It's like its sister. Okay? Average rate of change. So for average rate of change, we will be using this to approximate on an interval. So it's saying from one point to the next point, what is the rate of change? Okay? And so we are pretty much still using rate of change, but we now are approximating what's changing only on a specific amount of time. In calculus, you will be more precise and more exact with it, right? Right now, we're only doing approximations. Cool? We're going to dive a little deeper in the next section, which is 1A.3, which we'll do on Monday, because I actually see you all on Monday, okay? But then just remember, it's all about lines. How is it approaching? What is the line? If you can do a linear function and linear models, can you do this? Yes, because that's it. It's just new words, same concepts, okay? All right, so our main thing we want to be able to do is to estimate the rate of change by using the average rate of change over a small interval. Guess what that just means we're doing? Change in y over change in x, okay? We're just doing delta y over delta x. That's all it is, okay? And that's it. When it says tangent line, now that we're using a line, that means we're now putting things in terms of y equals mx plus Does that make sense? Do we know that? It may look different, but ultimately, those are the things that we would be doing. If you're looking for your notes, it's in the box. Is it not inside the box? Gotta take the box out. We're looking for this. Okay, it's not in your notes. Just pay attention. We'll come back to that. Are you sure it's not in the box? What I put in the box? I don't know. We're good. Don't worry. You don't need it. We're good. All right. So that was just it. I guess I added in there and forgot to put in your notes. It's all right. There we go. The figure shows the graphical function of h of x. H of x is just the name of the function. That's it. Every function, we call something different. It is saying, of the following, on which interval is the average rate of change h the greatest? Okay? So you're looking from what point to what point creates the what? What's our word? Steepest, right? In this case, we want greatest. We want the steepest what? What kind of line? Positive. We're looking for the steepest positive line. Does that make sense? So we're going to start where it's at. So we're going to work through this one together. Just make sure we're all good. So if I look from 2 to 3. So from 2 to 3. So here's 2. And here's 3. And I was to draw a line to connect 2 to 3. What happens? It's constant. The rate of change from 2 to 3 is? Eventually it's going to become a constant. Does that work? Is that going to be great? No. So now we're going to do the next interval, 3 to 5. So we're going to go from 3 and to 5. So from 3 to 5. Okay. Is that positive?
No.
No, we're not looking good here. So we're going to say the rate of change here is negative. Now we're going to go to 5 to 7. So from 5 up to 7. So this is what 5 to 7 is doing. Oh, that I can't even pretend that's a straight line. Dang it. To the PowerPoint people who make PowerPoint, please install a line tool. The math teachers of the world would greatly appreciate it. It would make my life so much easier if you had a line tool. Hopefully they hear this when the video goes on YouTube. All right, this one's okay. This is a contender. The rate of change is positive. Okay. And then the last one we have is from 7 to 8. So from 7 to 8, womp, womp, womp. What happens from 7 to 8? It is what? Negative. The rate of change is negative. So the winner is C. That is going to be our greatest. Now, was that terrible? I know y'all want to find a reason to be mad or complain today. You're not going to find it. Math is beautiful and pre-cal's wonderful. I said what I said. All right, on to the next. So the graph we don't have is y equals f of x is in the xy plane, has a negative rate of change. Which of the following definitions for the variables x and y would best model the function of f? Okay, so you're looking for a scenario. You're going to decide, based on the scenarios given, which one would model a negative rate of change. I'm going to give you 60 seconds to read and think about it. Which do you think would be the best model? Hit the little reset button. Boom, I did it. So using your math sense and your common sense, which would be the best scenario? A, B, C, or D? 5 seconds left. All right, raise your hand if you chose 8. Good job. You did. Because this wouldn't have been a good sign of your common sense. So I'm glad that you did not choose A. Good job. Because if you think as kids get older, they get shorter, we got a problem.
I get shorter.
You're getting shorter? I don't think you are, but okay. What about B? Okay, we got 1, 2. We got 2 for B. Okay. What about C? We got 1, 2, 3, 4, 5, 6. Is your hand slightly up, Christian? We got 7. I'm going to write this in Roman numeral. So I want to write out the tally marks. And D. We got a 1 for D. Okay, either I can't count or that's not everybody, but the winners are B. Okay, the reason why it is B is because if the points of the games are being scored, right, that means that over time, the time is doing what? The decreasing. The time would be decreasing because you're scoring. Time is doing what? Yes.
Obviously.
In order for something to be decreasing, your x's still have to be growing, but your time is here. And then this is this creates a quadratic model. That's why. Because you're growing in the ripple, your area of a circle. Think of pi r squared. That square in there is gonna have some hiccups in it. Okay, now let's talk about what if you are given a function, like an actual function, and it's giving you an interval from -10 to 10. Okay, it says which of the following statement is about k is correct. We would be looking to see what is happening on this interval. If I'm given the function, guys, guess what I do? Anytime that you have decimals in a problem, that's your key that it's going to be a calculator type problem, especially on the AP exam. Okay, if it's not pretty small, useful numbers, I don't think that's a thing, but you know what I mean. That's how we know it's going to have what kind of problem? A calculator problem. Okay, I'm going to model this in the calculator. I'm going to use. We did not use handhelds as much in pre-AP Algebra 2 as we probably should have. But we're going to use interchange both, okay? The reason why I encourage you to do both is because when you're taking the test, sometimes it is just faster to type things in front of you. Instead of having to use your mouse, toggle back and forth, if you get comfortable using the handheld, it makes things as simple calculations and such go really, really fast. Does that make sense? So that's why we will be learning both so that we can be like, math testers, okay? So in the calculator, if I'm given the function, I'm going to just simply type it in exactly how it is. So it says 3 and 1600ths plus 4 and 2/10 x minus 8500ths and x squared. That's on a square, Sean. Go back. Do better, girl. 2. All right, so this is me using the handheld. It gave me an interval from -2 to 10. On the handheld, when you're adjusting, that is going to be your x min and your x max. It's automatically set for -2 to 10 when you're using a handheld calculator, and that's the window it's going to show you at. So when I hit graph, it's going to show me the function from -2 to 10. I mean, -10 to 2. -10 to +10. I can talk. So looking here at our graph that I've done for you, which option would best fit the scenario? Oh, let me identify your max for you. Y'all need that value? No, it's at 0, but it's not quite at 0, so I'll tell you your max. 4. To the left. Now to the right. Now click. It's at -1. Points up, thumbs up. What do you think? So now that you're looking at it, which option do you think fits the situation? Guys, I put something in wrong. My graph didn't like this earlier. What did I type? Why didn't anyone tell me I forgot my X? Oh, this is not the right graph that I did in my notes. And y'all, no one was going to say, Miss Jones, these numbers don't match anything on our paper. We're just going to let her swim out here, drown. Thanks, guys. Good thing I take my notes beforehand. Because I clearly have to rely on myself.
I can't tell if she's being sarcastic or not.
Let's try that again.
You
You saw the thing. She's coming back.
I just want to.
Sylvie's a little slow. She's gray. You know, she's graying. So, but she gets the job done. Let me find the max for you again. So notice to find the max, I hit second trace, and you see it says maximum. It's going to go there, and you just got to go to the left of it. It tells you to the left, and then it tells you, please go to the right of it. And I'm going to click to the right of her, and boom. Okay, there are the numbers. The numbers are correct now. My bad, bro. I was like, I swear I wrote the right numbers down. So what is a true statement? Can someone tell me which ones you can automatically eliminate?
A.
Why can I automatically eliminate A?
Because the answer is negative first.
What does 8.34 represent? Y. And do we define intervals with our Y's? No, we do not, silly guys. So hopefully we notice that. Where do I have a negative rate of change?
B and C.
Or any of them. So what are my two true statements or positive? Any true statements? Anyone? Everybody?
Is it C?
We have here. You think C is a true statement?
No.
So if I go to C, so C is telling me from, what was the value? Negative 0.63. So this is negative 0.633. And it goes to positive 5. So if I go from here to 5, which is going to be on this side. Second trace. Oh, fudge. 5.605. They're actually what?
Constant.
Constant. And those are your zeros. So what does that lead to be our true statement?
Why are your eyes closed, child?
Say it again. D. D is our true statement. From our max to 10, what is it doing? Decreasing. So therefore it's a what? A negative rate of change. Did we see that?
Yes.
All right. The last part is example 6. I wanted you guys to practice finding the rates of change. And so basically you would be using change in Y over change in X. Okay. And you're going to compare to see which one produces the what? Greatest. Does that make sense? So this is an example of us having to find rate of change. And that's going to be our change in Y over our change in X. So on the first one, it says from 1800 to 1850. Okay. Our birth year is our X. Our life expectancy is our Y. So the change in Y here would be your 46.10 minus 41.24 over your 1850. That's 18. Trust me. Minus 1800. And that's what you're going to do for all four of them to decide, all four, to figure out which one is the greatest. Can we handle that?
Mm-hmm.
Yes.
Yes? All right. Questions about rate of change? Huh? I just told you, do you drive a car? Do you fill gas? Do you want to make predictions about your future? Do you want to save money? It helps you a lot. If you plan on being an engineer or a physician, business, yeah.